naught divided by pi, and I naught is the peak value of the current, or you can say the maximum value of the alternating current.
Yes.
Root mean square value of current for full cycle is equal to I naught by root 2 is equal to I naught by root. So basically today we will discuss the AC circuits. AC circuits means we will connect a resistor first with an alternating voltage. Okay, with alternating voltage we will connect resistance, we will connect inductor, we will connect capacitor, and we will see in the AC circuit what are the results of the EMF and the current. Okay, so basically we will discuss today this circuit theory. Circuit theory means we will discuss this basically the circuit. So first is a pure resistive circuit. Pure resistive circuit means you have connected a resistor with an AC source this time, with an AC source. Okay. This is a DC source. This sign represents the cell.
Yeah.
And cell is a DC source. We have discussed.
Yeah.
Cell is a DC source. Suppose you have connected the resistance like this. Suppose you have connected the resistance with a DC source. Okay, so this is a DC circuit. And what is this? This is an AC circuit. How we know that? How I know that this is a DC circuit? Because see the voltage value. This is the sign of the AC source. Sign of this is a symbol of the DC source or cell. This is basically this is a symbol of cell or a battery.
Yes, sir.
Yeah, this is a symbol of cell or a battery, and this is a symbol of the alternating voltage or alternating current source. What is the meaning of alternating voltage or alternating current source? A source which is giving an alternating current or an alternating voltage, or you can say a source which is supplying an alternating current or alternating voltage. So we know that the alternating voltage is given by V is equal to V naught sine omega t. V is equal to V naught sine omega t. What is V? V is the value of voltage at any particular time in this circuit. In this circuit, the value of voltage at any particular time. So in DC, we have a constant voltage basically. Okay, if you will calculate the voltage drop across this resistance, it will be constant. But here the voltage across this resistance will not be constant. It will change with respect to time, because here is a time, and we know time is passing. Every time the time is passing, at every second and every nanosecond, picosecond, you can take. Time is passing continuously. If time is passing, means time is increasing or decreasing? Increasing. Can time decrease? Time cannot decrease. No. Time is always increasing. If you are taking t is equal to 0, yes, then always it will be t is equal to 0.01 t, but means greater than 0. Yes. So means time is moving in a forward direction, you can say. So what is V? V is the value of voltage at any instant of time and V naught. Okay, I have told you the graph of the voltage. I have here I think we have discussed. Yes, sir. The graph of alternating voltage here. Okay, so this is basically the graph of the alternating current, and the graph of the alternating current and alternating voltage is same. So here you can write alternating voltage also. Okay, with time. So see, this is the graph, means, okay, we can change this graph. So this is the graph between the EMF and time, means with time how the EMF is changing. Yes. There is a time when the value of the EMF is maximum. This is the maximum EMF value. Yeah. This at this point, somewhere here, you will get the maximum value of EMF. Okay. Okay. So that is Emax is also known as E naught. or you can say V naught, or this you can write E max as V max also. Basically, E max is representing the EMF and V max is representing the maximum potential difference. So E is
Okay.
representing EMF, V is representing the potential difference. So okay, here V naught is the maximum value of voltage. Maximum value of voltage. Omega is the angular frequency. Okay. What is T? T is representing time.
Time.
So I am not writing that. This is sine omega t. So basically, this voltage is a function of sine. Voltage is a function of sine.
Sine.
Okay. And there is a relation between the angular frequency. If f is your frequency, na? F is your frequency. Then there is a relation between the angular frequency and the frequency, that is omega is equal to 2 pi into f. Omega is equal to 2 pi into f. Okay, so we will see this circuit. Here is this voltage source. Now focus on this circuit. This is the voltage at any time in this circuit. So what I am doing, and this is a resistor. This is the resistor or resistance. So I am supposing in this circuit, I am supposing, we know that the direction of the current and the magnitude of the current in this circuit is changing continuously with time.
Yes.
Because current is in the form of sine curve. So I have told you in alternating, alternating current changes with time in magnitude as well as in direction. Okay.
Yeah.
So here you can see if this is the current. So this current is changing with time at every point. If you are moving, time is going in forward direction. See, again the direction here, the direction is same in positive direction, but here the magnitude is changing. From here to here, the magnitude is changing. And at this point, if you are moving, if you are crossing this point, then the direction is changing. Here, direction is positive. Here, the direction of the current or EMF is positive. Here, the direction of current or EMF is negative.
Negative. Yeah.
Okay, so I am supposing in this circuit, there is a current I. There is a current I at any instant of time. There is a current I at any instant of time, and this is the direction of the current. Okay, because this is an alternating current, so I cannot say that about anything about the direction. Direction is continuously changing. So I am supposing I is the current at any instant of time in this circuit, at any instant of time. Okay. Yes. So now what we will do, we will apply in this circuit KVL. KVL means Kirchhoff's voltage law. Kirchhoff's voltage law we will apply, which says that summation of all the algebraic summation of all the voltages in a closed circuit is equal to 0. Okay. So we are moving in this direction. So you can choose any corner. You can choose any corner, and you will move along in a circuit along the sense of this arrow. This arrow is clockwise. So suppose you have choose this end. So you will move in this sense to see the voltage. So here, okay, see the voltage. So suppose you are moving from this end at any instant of time. Suppose this end is positive, this end is negative. I don't know right now this end is positive. I am just supposing at any instant of time this end is positive and this end is negative. So you will move from here to here to apply the KVL. You know na how to apply KVL, Kirchhoff voltage law. So we move in a circuit. I am moving like this. So this is a negative terminal. This is a positive terminal. So basically, I am saying that the negative terminal is a lower potential and positive terminal representing the higher potential. So you are going from lower potential to the higher potential. So basically, potential is increasing. So you will take this V as positive. V as positive. Now when you are moving, now you have moved, this is one voltage here, so we have written this one voltage and we have taken this as positive. Now we are moving like this, there is no voltage here, is also there is no voltage. Now across this resistance there is another voltage, there is voltage. Okay, there is voltage across this resistance also. So that voltage is equal to IR. V is equal to IR na. That voltage is equal to current in the resistance at any instant of time into the resistance. Why I am taking negative? Because we are moving in the direction of the current, and I have told you the direction of the current is direction of decreasing potential. Current flows from higher potential to the lower potential.
Yes.
So we are moving in a direction of the current, means we are moving in a direction of decreasing potential. That is why I have taken here a negative sign, and this whole is equal to 0. So what we will get? We will get V is equal to I into R. We will get V is equal to IR.
Yeah.
Okay. Now if I want to find the current in this circuit, so how I will write? I is equal to V by R.
V by, yeah.
So you will say, sir, why you have applied the KVL? I know that current is equal to voltage by resistance. Because there can be any other source of voltage also. In that case, you have to apply this. Okay. So we cannot write that current at any time is equal to voltage at any time divided by the resistance. Okay.
Okay.
Always we cannot write. Always I am talking about. So current is equal to V by R. So what is V? V from here.
Voltage.
V naught sine omega t. V naught sine omega t divided by R. And what is V naught by R? Remember, V naught is the peak voltage or the maximum voltage divided by R. This is given by the maximum current or I naught. What is I naught? Peak current or maximum current?
Maximum current, yeah.
So V naught by R, for this V naught by R, this V naught by R, I can write I naught. So basically we have an equation I is equal to I naught sine omega t. Okay, so now we will get the current equation. Now we will, oh, just a minute. Sorry. Sorry. Okay, so I is equal to I naught sine omega t.
Yes.
We get the equation of the current, and what is I? I is the current at any instant of time. I is the current at any instant of time. Now, with the help of this equation, we can find the value of the current in the circuit. We can find the value of the current in this circuit. Okay.
Yes.
So, okay, now see what is the equation of the voltage. V is equal to V naught sine omega t.
Yes.
V is equal to V naught sine omega t. Now see this. This, what is omega t? This is something. This is omega t. This omega t. Okay, the angle omega t will be some angle. Omega t will be some angle. Okay, so this angle with sign is known as the phase.
Phase angle, right?
Yeah, phase.
Okay.
Phase angle, you can say.
Yes.
Okay, so now phase difference. I want to calculate phase difference between the current and the voltage. So phase difference means phase of the voltage minus phase of the current, or you can say phase of the current minus phase of the voltage. This is the modulus. So this will give always the positive value. What is the phase of voltage? Tell me.
Phase of voltage.
See the equation first. If you want to find the phase of voltage, so this will be the phase of voltage, omega t.
Yeah.
This is the phase of voltage. This is voltage. This is a phase
Yeah.
of voltage. This is omega. This is
Omega
modulus,
t.
right? Modulus.
Okay.
Why we are writing the modulus here? Because we are interested in difference. Suppose, for
Okay.
example, I want to calculate 5 minus 3
Yeah.
of mod. I will get 2. If I am
Yes.
writing 3 minus 5, so what I will get? Minus 2.
Minus 2.
Minus 2. And mod of minus 2 is equal to 2.
Yeah.
So now
Okay. Yeah.
I think you have
Yeah.
understood what I want to
Yes,
say.
sir. Yes.
We want only the difference.
Yeah.
Okay. So this is omega t. What is the voltage of the current? Omega t.
Yes, sir.
So your answer will be, answer of this will be omega t minus omega t. 0.
0. 0.
If you are writing 1 minus 1, then that will be 0, na?
Yeah. 0.
Omega t minus omega t is equal to 0.
Yes.
Okay. Phase difference. So you can say phase difference between the current and the voltage is equal to 0. So you can say that current and voltage are in same phase. Current and
Yeah.
voltage are
Yes.
in same
Same.
phase. So you can write current and voltage are in same phase. So to describe this, how the current is changing and how the voltage is changing and what is the phase difference and how to interpret all these things, we draw a diagram known as the phasor diagram.
Yeah.
We draw a
Phasor
diagram known as the phasor diagram. So why we
Yeah.
draw the phasor diagram? Because we want to analyze this circuit. We want to analyze this circuit. Okay. So to analyze the circuit, it is better. It is better to draw the diagram and show the direction of the voltage, show the direction of the current. Then you have some idea about the current and the voltage. Okay. You can
Yes.
find from that diagram the voltage at any time and my peak value of the voltage. So basically the phasor diagram we will discuss. So phasor diagram, for the to draw the phasor diagram, you will draw two axes. Okay, there is a requirement of two axes, y axis and x axis.
Yeah.
And you will write the equation of voltage. This is the equation of voltage we got from here. Equation of the current is this: I is equal to I naught sin omega t, v is equal to v naught sin omega t. So
Yes.
equation of voltage was this in this circuit, and equation of the current, I is equal to I naught sin omega t. Okay, so now see this peak value. See this peak value. So what you will do, you will draw like this. You will draw an arrow from the origin, passing from the origin, and this length of the arrow is representing the value of V naught. The length of the arrow representing the value of V naught. Okay,
Yes.
and this
Okay.
omega t is the angle. So this angle you will draw with x-axis.
Okay.
And if you will take the projection of this V naught if you will take the projection of this V naught on on this axis, on y axis, so you will get the voltage V. What is V? The voltage at any instant
Voltage.
of time.
Yeah.
So V will be the instantaneous value of the voltage. Now for current, how you will draw? For current, how you will draw? We know that I naught is equal to V naught divided by R. So you
Yeah.
can say that here your value of the current, here your value of the current I naught is less than V naught. So means we will draw a arrow again. We will draw a arrow again, and the length of the arrow will be smaller than the voltage because the
Yeah.
current is smaller than the voltage. So this is suppose I naught. And how you will write the angle with x-axis? This omega d. Angle is same.
Yeah.
Here is angle same for the current. Here is angle same for the voltage. That is why the phasor diagram of both current and the voltage will coincide.
Yes.
So for current, if you will draw the projection on the y-axis, so you will get the instantaneous value of the current. So basically from here, from this diagram also, you can see that the current and the voltage are in same phase. What is the meaning of same phase? They are making a equal angle with x-axis. With this axis, they are making an equal angle.
Yeah. Yes.
So okay, in simple way, if you want to draw the diagram, then you can draw like this. This is the voltage. This is the voltage, and voltage across the resistance you can write, or and this is the current. This is the current. This is the voltage. So both are in same phase. Current and voltage are in same phase.
Yeah.
So basically, this is your simple diagram. So in numerical, you can just draw this diagram and easily you can solve the numerical. We are not going to draw this diagram in numericals again and again. Okay? If there is a requirement, then we will draw this. Otherwise, we will draw the simple diagram. Okay, so both are in same phase. Now there is one more diagram, wave diagram. So wave diagram, I think I have already told you, this is the equation of the voltage and this is the equation of the current in the purely resistive circuit. This is the equation of the current. Now this yellow color graph, first see this V and I.
Yes.
Both are the function of the sign. Okay, so means V is changing according to the sine curve and I is also changing according to the sine. So basically, if you will draw the wave diagram for the voltage, then it will be like this. Why it will be like this? Because the value of V naught here, you will get value of V naught, and here you will get value of I naught. So
Yes.
we know that V naught is greater than I naught. V
Yeah.
naught is greater than I naught. So that is why this diagram is upper than the current diagram. Current diagram is lower like this.
Yes.
Because the peak value of the voltage we are getting in upper, means somewhere here we will get, and the peak value of the current somewhere here we will get. So basically here here we can see from this graph, this voltage is greater than the current. Okay,
Okay.
so that is why we have drawn this. That, and what is this t? T is the time period. T, I have told you now. What is
Yes.
t? So t is representing the time period. Time, and this is representing, this point is representing the half of the time period. This is representing half of the time period.
Yeah.
This is representing 1/4 of the time period. Means you will get the maximum value of the current and the maximum value of the voltage at t by 4. At t by 4, you will get the maximum value of the current and the maximum value of the voltage.
Yeah.
You can put the value of time t is equal to t by 4 and you will get the value. Just I am showing how you will get the value maximum at t by 4. So at t is equal to t by 4, okay, you want v. So you will write equation of v is equal to v naught sine omega t. So v is equal to v naught sine omega. Instead of t, what is you have? T by 4.
Yeah.
And there is a relation between omega and time. Omega is 2t by, oh, omega is equal to 2 pi by t. Omega is equal to 2 pi by t. This is the relation. So v is equal to v naught sine, instead of omega we will put 2 pi by t multiplied by t by 4. So basically here this t and t will be cancel out. This is
Yes.
2 2s are 4. So what
Yes.
we will get? Pi by 2.
Pi by 2. Yeah.
And sine pi by 2 is 1.
Yeah.
So
1.
basically you will get v is equal to v naught.
Mm.
So what is v naught? Maximum value of the
Maximum
voltage,
value.
and you are getting at t is equal to t by 4.
Yes.
Okay, take the screenshot.
Okay. Done. 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 Done.
Okay, so what we get from the purely resistive circuit, if we have a purely resistive circuit, what is the equation of the voltage? Equation of the voltage, we will take this. V is equal to v naught sine omega t. This is the equation of the voltage. And what is
Yeah.
the equation of the current? I is equal to I
I is
naught
I
sine
know.
omega
Yeah.
t.
Yes.
So omega t and omega t is there. So phase difference between the current and the voltage is 0.
Yes.
So I think this thing you should remember. Okay. So after this, we will discuss the purely inductive circuit. So what is the meaning of the purely inductive circuit? We will connect an inductor only. We will connect an inductor only with the alternating source. With an alternating source. So purely inductive circuit. So okay, so this is your purely inductive circuit. So this is your inductor, and this
Yeah.
inductor is connected with an alternating voltage source, and L is representing the self inductance of the inductor. This inductor has the self inductance. And what is V naught peak value? Omega is the angular frequency, T is the time, V is the voltage at any instant of time. Before that, I want to tell you something about the inductor. We have already discussed this. In an inductor, what happens? Inductor always opposes the change in the current.
Yeah.
If in an inductor the current changes due to the induction, what happens? There is a EMF induced in that inductor. E is equal to L di by dt.
Yes.
E is equal to L di by dt. So inductor opposes the change in current. You can write here. change in current. Inductor opposes the change in current. And alternating current is always changing. Alternating current is a changing current with time. So there is an inductor. Due to this source of voltage, there will be the current in the circuit. Suppose I is the current in the circuit at any instant of the time.
Yes.
And what type of current this is? Alternating current. Alternating current means the current is changing with respect to time.
Yes.
So if this current is, if changing current is flowing in the inductor, but inductor opposes the change of current by producing the induced EMF. So what this inductor will do? This inductor will induce an EMF E, and that EMF E is given by L di by dt.
Yeah. Yes.
Change in current divided by time. Okay. So now with the help of this equation, we will try to find the equation of the current. We will try to find the equation of the current. And this is the EMF induced. What is E? E is the EMF induced by the inductor. EMF induced by the inductor. This thing
Yes.
you should know. Okay, so here also we will apply the Kirchhoff's voltage law. We will apply Kirchhoff's voltage law. You can write KVL, Kirchhoff's voltage law. Kirchhoff's voltage law. So I am choosing this direction of circuit. This direction means this is the clockwise direction. So means we will move in a circuit in
Yeah.
clockwise direction. You can choose any point from where you want to move through the circuit. If you are choosing this point, then you are going in a clockwise direction. So at any instant of time, this is suppose plus, this is minus. Okay, this is plus, this is minus, because here the current direction is this. So current always flows from positive terminal to the negative terminal. Okay, so you will apply the KVL. So you will get this voltage. You are moving from negative to positive. So you will take this V as plus V. And in an inductor, this inductor will produce a current in the opposite direction. So what will be the current in the opposite direction? Okay. So here the current will flow in an inductor. The current will flow in the opposite direction. Okay.
Okay, sir.
So if you will apply the Kirchhoff's voltage law, so this EMF you will take negative, because you are moving from positive terminal to negative terminal. Okay. So
Okay.
you will take this minus E is equal to 0. So V minus E equal to 0 you will get. And what is E? Actually this E will be minus L di by dt.
Yeah.
Minus L di by dt. Okay.
Mm.
And this is the positive terminal, this is the negative terminal.
Yes.
This is the positive terminal and negative terminal. So basically here will be the negative terminal, here will be the positive terminal, here will be the negative terminal, here will be the positive terminal at any instant of time. So that's how the current will oppose this current. Okay.
Okay.
Because current always flows from positive terminal to negative terminal. So induced current in this coil will be in this direction. So we are not interested in that. Okay. So simply I want to tell you, you will take this E as plus E. Now take this as plus E, and that is equal to 0. And what is the value of E? Minus L di by dt. So you can write V minus L di by dt is equal to 0. So you can write P is equal to L di by dt. You can write for current, di is equal to V dt by L. What is V? V is equal to V naught sin omega t.
Yeah.
And dt by L.
Okay.
And now this is di. So di is the small current. Okay, di is the small current. To get the total current in the circuit, you will integrate this equation. So when you will integrate, you will get the total current, and this will be V naught by L, and integration of sin omega t will be cos omega t by cos omega t multiplied by omega, divide by omega. So you will get cos omega t minus cos omega t divided by omega.
Yes.
So integration of sin omega t will be, integration of sin is minus cos.
Yes.
Integration of sin is minus cos. So when you will integrate this sin omega t, because this V naught by L is constant, so that is why I have taken it outside.
Okay.
So you will get finally I is equal to V naught by omega L. Okay, V naught by omega L minus cos omega t. Minus
Okay,
cos.
so we took omega out.
No, we cannot take omega out because omega is the angle. Omega is the angle. We cannot separate omega. Actually, we will do a different thing. We will do a different thing. Okay, so this term V naught by omega L is known as I naught. This V naught by omega L will be I naught. So you can write this V naught by omega L, I is equal to I naught, and this is minus cos omega t.
Okay, sir.
What is your I naught? I naught is equal to V naught by omega L.
Yeah.
Now here there is a new term introduced. Current is, we know that current is voltage by resistance. So this thing will be like, this will be something like the resistance. And this will be something like a resistance, and here is the inductor. Here is the inductor. So this thing is known, omega L is known as the inductive reactance. Omega L is known as the inductive reactance. And this inductive reactance is represented by X suffix L. X suffix L. So inductive reactance XL is given by omega L. XL is given by omega L.
So that's inductive reactance.
Yeah, it is inductive reactance.
Okay.
Like resistance na, in the resistive circuit. So in inductive circuit, we have inductive reactance. This is also a resistance. This is also a resistance. Okay, got it?
Yes. So should I take screenshot?
Just a minute.
Done.
Taken?
Yes. Done.
Okay, now see this. I have written some formulas here. Sine 90, and 90 in radian is written as pi by 2. So sine 90 minus theta or sine pi by 2 minus theta is equal to cos theta. So cos theta can be written as sine 90 minus theta.
Yeah.
means omega is also some angle. So cos omega t can be written as sine 90 minus omega t. Okay. Or you can write cos omega t sine pi by 2 minus omega t.
Pi.
Okay.
Yeah.
So
Okay.
this equation is this I is equal to minus I naught. And this cos omega t can be written as sine pi by 2 minus omega t.
Omega.
This is the
Yeah.
trigonometry of 10th class. Okay, trigonometry.
Okay.
I have written all the related formulas so that this will be easy for you. Okay, so sine pi by 2 minus omega t. But please always remember that this omega t must be positive. We want this omega t
Okay.
positive. Okay, so what we will do, we will write this I is equal to minus I naught sine. Okay, so we will take minus sign common, so it will become omega t minus pi by 2.
Okay. So it will multiply inside.
Yeah. So actually, what is this? This is sine minus of theta. This will be the some angle, na? This will be some angle of sine.
Yes.
So sine minus of theta is equal to sine minus of theta is equal to minus sine theta. Remember this. And cos of minus theta is equal to cos theta. Okay, sine of minus theta. So this will be the case. So what you will get here? You will get another minus sign. You will get here sine of minus theta. You will get minus sine omega t minus pi by 2, and minus minus become plus. Minus minus become plus. So you can write I is equal to I naught sine omega t minus pi by 2. So this is the final equation of the current you will get. So this is your final equation of current. So now the equation of the voltage is different from the current. So equation of the voltage was this, and equation of current is this. So we will draw the phasor diagram of both these two. And what is this omega t minus pi by 2 representing? This omega t minus pi by 2 is representing the phase. This is representing the phase. And what is 5? 5 was the phase difference. 5 was the phase difference. So how you will write? You will write omega t. You will write omega t minus of omega t minus pi by 2. So this will be your phase difference omega 5. This will be omega t minus omega t plus pi by 2. So what will be your phase difference? Pi is pi by 2. So this time the phase difference is pi by 2. In the purely resistive circuit, the phase difference was 0. Now we will plot for the voltage and for the current, the phasor diagram we will plot. So see how we will draw that. Two axes you can take and draw this. This is the voltage V0, and see the phase of voltage omega t. So means this voltage is making an angle of omega t like this. Now current, here the value of the current.
Yes.
Current is omega t minus pi by 2. So current is lagging behind from the voltage. You can see the phase of the current. Phase of the current is omega t minus pi by 2.
Yeah.
So means current is 90 degree behind from the current. So for the current, we will draw the phasor like this. Current will be like this.
So 90 degrees, right?
Yeah, here you can see na phase difference phi is 90 degree. Pi by 2 is 90 degree.
Yeah.
Pi by 2 is 90 degree.
Yeah.
Basically, this is your I naught. And when you will draw the projection you will get V, and when you will draw the projection here, you will get I, and this angle will be of 90 degree, this whole angle. Why this angle is 90 degree? Because this current is lagging behind from the voltage by 90 degree. That is why this angle is 90
Okay.
degree.
Okay. Yeah.
Okay, so you can take the screenshot from here.
Yeah.
Remember one thing, this XL is the resistance, this XL is like the resistance, so unit of this will also be in ohm. So
Okay, sir.
unit will be
Mm.
ohm. This is the symbol of ohm. Like
Okay.
unit of resistance, SI unit of resistance
Yeah.
is ohm, na?
Yes, sir.
So
Done. Sir.
so what we can conclude from this diagram, this current is lagging or leading? This current is leading or this
La
current is lagging?
lagging. Lagging.
Lagging.
Yeah.
You can write current lags behind potential or potential difference. Why? Why? 90 degree.
90 degree.
90 degree, you can write also pi by 2 also.
Yeah.
Because 90 is in degree, pi by 2 is in radian.
Yeah.
Yeah. Okay. So now there is a graph. We will draw the graph between this XL. XL means inductive reactance versus the frequency. Inductive reactance versus frequency. We will draw. So see how we will draw the graph. We know that uh, we know that XL is equal to omega L, and omega is equal to 2 pi f into L, means your XL is directly proportional to L. So
Yeah.
the graph you will get will be like this. The graph you will get will be like this. On this axis, you will take XL. Here you will take frequency f. So as XL is directly proportional to L, so
Yeah.
graph will be linear. So graph will be
Mm.
linear. We have already drawn a graph. Means
Yeah.
if you know in Ohm's law, what is Ohm's law? Potential difference is directly proportional to the current at some specific conditions. So there we get a straight line graph between the voltage and the current. So here also we will get a straight line graph. We will get a straight line graph. So this will be the graph between the voltage and EMF, between the XL and F. This is the graph. If you want to draw the wave diagram now, if you want to draw the wave diagram, so you can draw with the help of these equations.
Okay, sir.
With the help of these equations, you have equation of the current I is equal to I naught sine omega t, I is equal to I naught sine omega t minus pi by 2.
Yeah.
Equation of the voltage V is equal to V naught sine omega t. So you can draw the graph accordingly. Okay.
Okay, sir.
So if you will draw that graph, wave diagram, then how you will draw the wave diagram? wave diagram, for wave diagram, we should have the equation of the current and the equation of the voltage. Equation of the voltage is V is equal to V naught sine omega t. Equation of the current, I is equal to I naught sine omega t minus 90 degree or minus pi by 2.
Pi by 2. Yeah.
So basically this sine omega t minus pi by 2 can be written as I is equal to, so I have told you sine uh, omega t minus pi by 2 you can write, so you will get minus cos omega t. Okay, so you will get minus cos omega t. So the current graph will be of in form of cos omega t, and the voltage graph will be in the form of sin omega t. So when you will draw this, so you will get this kind of graph. For the voltage, the graph will be like this. So we have sine curve, and for current you will get the graph like this. So here the value of the voltage will be 0. Here the value of the voltage will be maximum. Here is 0. Here will be maximum in negative direction. Here is 0. Here is again maximum. Here is
Yes.
again 0.
Yeah.
Okay. So you will draw the graph like this. You will get so you have to draw the graph. Okay. So this kind
Okay.
of graph you will get. Actually, I have to make it different color. This kind of something you will get the graph. Actually, this is will be the graph of cos. So this is the graph of the voltage, and this is the graph of the current. So here you can see that there is a phase difference of 90 degree between the voltage and the current.
Okay.
Okay, take the screenshots.
Yeah. Done. Done.
So here will be the peak value of the current, here will be the maximum value. I have told you.
Yeah.
Okay, so from this inductive circuit, what is the equation of the voltage? V is equal to V naught sine omega t. What is the equation of the current? I is equal to I naught
Sine
sine
omega t
omega t minus
minus.
pi by 2.
Yeah. Nice.
Or you can write this equation like this: I naught
Sine
sine omega t minus 90
minus
degree.
90. Right.
So this is the question. So this is the inductor.
Yeah.
This is the inductor, and it have the self inductance of 2 Henry. And voltage source is connected. V is equal to 10 sine 10t plus 30 degree. Okay, this is the voltage. Find the equation of the current versus time. Find the equation of the current versus time. Basically, from this voltage equation, we want the equation of the current, and also calculate the root mean square value of the current.
Yeah.
So, what is the equation of the voltage in inductor? We have written V is equal to V naught sine omega t. Now you can compare this equation and this equation. From these two equations, you will get V naught as 10 volts. Okay, because this is 10, this is V naught, and this is sine omega t. Sine omega t.
Yes.
Okay.
Oh.
But here there is one more thing given. There is one more thing given. This is your 10t and this is your 30 degree angle. Okay, this is your 10t, this is your 30 degree angle. So
Yeah.
you can write this in this form. This is 10 sine. Basically, first we will calculate what is the omega and what is the peak value of the voltage. Okay, so peak value of the voltage we will get 10 volt, and omega, the coefficient of the time will be omega. So coefficient of the time here is 10. Okay, so omega is 10. Omega is 10 radian per second. Omega is 10 radian per second. Okay, so now we want the equation of the current versus time. So tell me, what is the equation of the voltage in inductor is this we have, and equation, what is the equation of the current? I is equal to
I is equal to
I naught sine omega t minus pi by 2.
Pi by 2, yeah.
This is the equation of the current we have.
Yes.
Okay. So this is the phase of the voltage. Yes. And we know that in the purely inductive circuit, the current lags behind 90 degree from the voltage.
Yeah.
Okay, so the phase of the current will be 90 degree less than the phase of the voltage. So this voltage is given to you. This is the general equation. Okay, so basically this equation in actual you have 10 sine 10t plus 30. So you will compare this equation with this. V is equal to V naught sine omega t. Okay, and you can take some initial phase of the voltage. Initial phase of the voltage is 30 degrees given. So when you will compare, you will get value of V naught and you will get value of omega. Now when you will write the equation of the current, and here phase of the voltage, initial phase of the voltage is given as 10t plus 30. Okay,
yeah.
Okay, so this will be 30 degree, 5b will be 30 degree. So you can write for sine, you can write whole phase of the voltage. This is the phase of the voltage, 10t plus 30 degree, and this phase will be 90 degree less. So this you will subtract. So this will become I is equal to I naught sine 10t minus 60 degree. So this is the equation of the current you will get.
Yes.
And they are asking the root mean square value of the current. So for the root mean square value of the current, I have told you I RMS is given by peak value of the current divided by root 2. So calculate first the peak value of the current. I naught is equal to V naught by XL. And what is XL? XL is equal to omega L. So V
Yeah.
naught by omega L. So what is the value of the V naught? V naught is 10. Omega is again 10. L is 2. So this will become 0.5 ampere. I naught is 0.5 ampere. So basically I RMS is equal to 0.5 by root 2 ampere. Okay, take the screenshot.
Done. Yes. Done.
So this is very easy question. This question. Find the inductive reactance of an inductor L is equal to 2 Henry connected to an AC source of frequency 10 Hertz. So here we have one inductor, have the self inductance of 2 Henry, and this is connected to an AC source. AC source is represented like this. AC source.
Yeah.
Frequency of this AC source is given as 50 Hertz. And they are asking inductive reactance. What is inductive reactance? XL.
Yeah.
What is
Yes.
XL? Omega L. Omega can be written 2 pi F. So this will become 2 pi FL. So 2 pi, what is frequency? 50. L is 2. So finally you will get 200 pi ohm. Take the screenshot.
Done.
Okay. So now we will discuss the pure capacitive circuit. We will discuss pure capacitive circuit. Means the capacitor will be connected with a voltage source, alternating voltage source. And what is C? C is the capacitance of the capacitor. We know that charge on the capacitor is given by Q is equal to C into V. V is the potential difference. So you can write V is equal to Q by C. So potential difference across the capacitor is given by Q by C. Across the capacitor is Q by C. And when you will apply in this circuit KVL, when you will apply in this circuit KVL, so you can write this V, you are applying the KVL in this direction, means you will get V minus Q by C is equal to 0. So from this equation, you will get Q is equal to CV and C is C and V is given as V naught sine omega t. V is given as V naught sine omega t.
Yes.
Okay. We want the equation of the current. And what is current? Current is equal to dq by dt. So we will differentiate this equation. V naught C into V naught sine omega t. So C and V naught will be taken as common, and sine differentiation of sine omega t. This is differentiation, not the integration. Is cos omega t into omega. So you will have omega c V naught cos omega t. This is the equation of the current. So I can write this equation as V naught divided by 1 by omega c V, and this is cos omega t. This is cos omega t. So basically this is your I naught. This will be your I naught. So I naught will be V naught divided by 1 by omega c, and this 1 by omega c is capacitive reactance. This 1 by omega c is known as the capacitive reactance. This is represented by Xc. So Xc is 1 by omega c. Now further what we will do? We have this. So I can write this equation of the current as so I can write this equation of the current. I is equal to I naught. This is I naught. So I is equal to I naught cos omega t.
Yeah.
I is equal to I naught cos omega t. So here we have this. So this thing you should know. Sine 90 plus theta is equal to cos theta. Sine 90 plus theta is equal to cos theta. So sine, so you can write cos omega t is equal to sine 90 plus omega t, or you can say sine omega t plus 90. So you can write I is equal to I naught sine omega t, not sine, sine, sorry, sine omega t plus 90 degree, or you can say pi by 2. So final equation of the current is this. Final equation of the current will be this. So you can see the current is this time leading. Here is plus pi by 2 na? Plus pi by 2. So current is leading from the voltage. Why pi by 2? Okay, so we will draw the phasor diagram. So what we get from the circuit equation of the voltage is V is equal to V naught sine omega t. What was the equation of the current? I is equal to I naught sine omega t plus pi by 2.
Yes.
So if you will calculate the phase difference, what you will get? Omega t minus omega t and minus pi by 2. You will take the mod, you will get the phase difference between the current and the voltage as pi by 2. So this time when you will draw, this will be your voltage, and your voltage will be making an angle of omega t, but this time your current will be this I naught, and this angle will be 90 degrees. So current is like this because current is leading this time by voltage by 90 degree. Current is leading from the voltage by 90 degree. So that is why I have drawn the current in like this. Okay.
Okay, sir.
So we know that if we will draw the graph between the capacitive reactance Xc, Xc is the capacitive reactance. What is Xc? Capacitive reactance. Reactance. So Xc is equal to 1 by omega c. So Xc is equal to 1 by 2 pi fc. So Xc is inversely proportional to the frequency. So the graph will be like this. This time capacitive reactance is inversely proportional to the frequency. So your graph will be like this. Okay. Rectangular hyperbola type graph. Here you will be your Xc, here will be your frequency. Okay, copy this.
Done. Done. Done.
Okay. So one question I am taking. See, voltage equation is given, and here is one capacitor. So we have to find the current and average value for full cycle for the current and average value for half cycle for the current.
Yeah.
So equation of the voltage was V is equal to V naught sine omega t. So
Yeah.
when you will compare the voltage equation, so you will get V naught is equal to 10 volts and you will get omega is equal to 10 radian per second. So equation of the current, we have I is equal to I naught sine omega t plus 90 degree. This
Yes.
is the equation of the current here.
Yes.
Okay, so we can write the equation of the current. For that, we should know what is I naught. So I naught can be calculated by V naught by Xc. What will be Xc? 1 by omega c. Okay, Xc is 1 by omega c.
Yeah.
Okay, so what is your V naught? V naught is equal to 10. 1 by omega is your 10. What is c? C is your 2 into 10 to the power minus 6.
Yeah.
2 into 10 to the power minus 6. So basically the current you will get, this can be written as 10 into 2 into 10 to the power minus 6 divided by and multiplied by 10. So basically this will become 2 into 10 to the power minus 4 ampere. This will be your current. This will be your current. I naught.
Yeah.
Peak value of the current. So your equation of the current will become I is equal to, we have the value of the I naught. So put the value of the I naught, 2 is equal to 10 to the power, 2 into 10 to the power minus 4. Sine, we have the equation, we have the omega 10t plus 90 degree.
Yes.
And they are asking in the second part, average value for full cycle. We know that average value of the current for full cycle is equal to 0.
Yes.
And average value of the current for half cycle is equal to
2
2 I naught by pi.
Yeah, 2 I naught by pi.
So I naught is 2 into 10 to the power minus 4 by pi. So you will
Yes.
get this value in ampere. Okay, Ziyad, note down.
Okay, sir. Done, sir. Done, sir.
So till now what we have done, see once. In pure resistive circuit, equation of the voltage is equal to, equation of the voltage is V is equal to V naught sine omega t.
Yeah.
Equation of the current I is equal to I naught sine omega t.
Yes, sir.
Omega t and omega t phase is same. So phase difference between the voltage and the current is 0. Means voltage and current are in same phase. Okay.
Yeah. Okay.
So, and the peak value of the current is given by V naught by resistance.
Yeah, we know.
In pure inductive circuit, we have the equation of the voltage V is equal to V naught sine omega t. Equation of the current. In inductive circuit, the current lag behind the voltage by pi by 2. So equation of the current is I equal to I naught sine omega t minus pi by 2. So current here is lagging behind the voltage by 90 degree.
Okay. Yeah.
Okay, here is in pure inductive circuit, instead of resistance, we have the
Voltage.
inductive reactance. That is known as XL. XL is given by omega L and omega is 2 pi F. So you can find I naught. I naught is equal to V naught by XL. In pure capacitive circuit, the equation of the voltage is equal V is equal to V naught sine omega t.
Yes.
And equation of the current, I is equal to I naught sine omega t plus pi by 2.
Yes, it's ahead.
In capacitive circuit, in
It's
capacitive
ahead by pi
circuit,
by
the
2.
current is leading the voltage by pi by 2 or
Yeah.
90 degree.
Hmm.
Pi by 2 or 90 degree.
Yeah.
So in capacitive circuit, we have capacitive reactance, that is Xc. Xc is
Yes.
given by 1 by omega c. So
Yes.
you can find the peak value of the current in this circuit, that is I naught is equal to V naught by Xc.
Yes.
So basically, we have completed the pure resistive circuit
Yes.
with an alternating source of voltage, pure inductive circuit. Then we have seen pure capacitive circuit.
Yeah.
So all these concepts of these circuits will be used in the next lecture. Next lecture will have the topic series LCR circuit. We will see a circuit in which all of these three will be connected together.
Okay.
All of these three means the resistance, inductance, inductor and the capacitor will be connected. Circuit will be like this. There will be one resistance, there will be one capacitance, there will be one inductor.
Yeah.
These three will be connected with an alternating source. Okay.
Okay.
Resistance, capacitance, and inductance L. This is resistance, this is capacitor, this is inductor. This inductor have the self-inductance L. This capacitor has the capacitance C. This resistance has the resistance R. And what is this?
Yes.
This is a voltage source,
Voltage,
alternating voltage source. So in the next class, we will see what will happen when we will connected all the components, means all of these three components with the alternating source. We know that in resistance, voltage and current have the same phase.
Yeah.
In capacitance, in capacitive circuit, we have voltage like this and current like this. Current leads the voltage by pi by 2.
Pi by 2. Yeah.
But in case of inductor, current lags behind the
Lags
voltage by
behind
pi by 2.
pi
So
by 2.
all
Yeah.
these concepts should be clear. We will use all these concepts in the next lecture.
Yeah.
So basically, you should revise this portion. Okay.
Okay, sir.
Means you should know, if I suppose in the next class, if I am asking for the inductor, tell me the equation of the current. So you will say I is equal to I naught sine omega t minus pi by 2. Why
Okay.
minus pi by 2? Because current is lagging
lags
behind in the
behind
inductive
by
circuit.
pi by
If
2.
I am
Yeah.
asking, suppose, tell me the equation of the current for pure capacitive circuit. So you will think for a second and you will say I is equal to I naught sine omega t plus pi by 2. Why plus pi by 2? Because in
it
inductive
leads.
circuit,
Yeah.
current leads the voltage by
Pi by 2.
pi by 2. Okay.
Yes.
And in resistance, in resistive circuit, current and voltage are in same phase.
Are the same.
So
Yeah, same.
both equation of the current and voltage will be same.
Yes.
Here is some phase difference, here is some phase difference, pi by 2 phase difference.
Yeah.
Phase difference basically telling you whether whether one quantity is leading with respect to other quantity or lagging with respect to other quantity. Phase difference is telling. Okay.
Yeah.
So in this circuit, if I am talking about the purely inductive circuit, so in this circuit, the phase difference of voltage is more, not the phase difference, phase of voltage is more than phase of current. Okay. That is why the voltage is leading the current by pi by 2. Initial phase of voltage is greater than the initial phase of the current. Okay, Ziyad, so that's all. We will meet in the next class and make sure that revise this properly. Okay.
Okay.
So basic things, at least you should know what is the average value of the current, what is the root mean square value of the current, what is the equation of the voltage, what is the equation of the current, what is the equation of the current and voltage in resistive, inductive and capacitive circuit. So without these concepts,
Yes.
We cannot understand properly the series LCR circuit, this circuit that we are going to discuss in the next class.
Okay.
Okay, Ziyad. So
Okay.
make sure that please